What we're going to talk about today are measures of center, and they're going to be things that you've heard of before. The first thing is the mean, and what the mean is an average. And the mean of a data set is a measure of center. If we imagine each data value to be a weight, then the mean is a point at which the data set would balance. And if you look at the scale, you see where, say those were your scores on exams, you can see that the mean is where the scale would balance out. When we talk about notation for a mean, I want to talk about a population and a sample. Recall that a population consists of an entire collection of individuals about which information is sought, and a sample consists of a smaller group drawn from the population. The method for calculating the mean is the same for both, however, the notation is different. So remember, our population might be something like all students at SU, and that would give us a population parameter. Our sample would be a simple random sample that we take, and that would give us a statistic. And what the population mean is, this is if I say I was looking for average height and I measured every student at SU. This is the Greek letter mu. And it looks like a U with a tail. So I'm going to draw a couple of them, and I want you to practice drawing a couple. It looks like this. It looks like a U with a tail. And a sample mean looks like this. A sample mean is an X with a bar on top, and it's just read as X bar. I want to talk about finding a mean. Let a list of little n numbers is denoted by this, x1, x2, ... all the way to xn. And when you see this symbol, you know from Algebra 2, it represents the sum of these numbers. When you do a mean, you're going to do a sum. And anytime you see a little n, it means the size of the sample. And when you see a big N, it means the size of the population. So when you see something like this, when you see something like the sum of x sub I, what it means is you're going to take all of your x's, x1, x2, all the way up to whatever xi is, and you're going to sum them. You're going to add them up. Now, if you have a sample, the sample mean is given by this notation. It's X bar because it's a sample. And what you're going to do is take the sum of all your X's, and you're going to divide by little n, the size of the sample. And notice this one is population. It's got the big N. The population mean is given by mu, and you're going to take the sum, and you're going to divide by big N. When you have a question, like this would be an Alex question, it's talking about an exam. A student took 5 exams, and it's telling you the population because it's telling you that you need to use mu. So here's what I'm going to do for this problem. I'm going to say mu equals, I'm going to add my scores, and I'm going to divide by big N, the total in the population, 5 exams. Take your calculator and enter the numerator and push equal. Anytime you have something like that, you need to push equal before you divide by 5. So here's what I get. When I add them and push equal, I get 406 divided by 5, which is 81.2. So the population mean is 81.2. Anytime if I go too fast and you're typing, just pause the video. I want to talk about sample mean and population mean. It's often impossible to compute a population mean because we don't know all the values in the population. Instead, we draw a sample and we use the sample mean as an estimate. That is, X bar is often used to estimate mu. Sample means usually, and this is what happens with the sample means, usually it either overestimates or underestimates the population mean. And I'll give you a little example before we do this. Say this summer, I measured every male student at SU, and I got their average height to be 5'9". And then what I do is I send you out and I said, okay, you guys take a simple random sample of 10 male students and tell me their average height. You guys come back and give me X bar. And your X bar, I'm going to say should in quotes, it should be 5'9", because that's what's true. But a lot of you would get X bars that are not 5'9". Like you might get 5'8". You might get 5'10", and they're going to vary. And that's just because of chance in sampling. It's because of chance. So a lot of times what happens is this X bar over or underestimates mu. And I'll give you an example from your text. There are 440 players in the NBA. The population mean is 79.2. You take samples of 5 players. So what you should get, and I'm going to say should like this, what you should get is 79.2. All right, but what happens when you take a sample, like if you look at this first sample, they got 80.2. That is too big. The second sample, they got 78. That is too small. The 80.2 overestimates mu, and the 70 overestimates the 79.2, and the 78 underestimates it. So that's what happens when you take a sample. And we're going to get into that a lot this year. So what do we do about it? A lot of people say that the mean represents a typical data value. In fact, this isn't necessarily true, because the mean may be a value that is not even in your data set. Like if you look at those problems, 80.2 look at 80.2. It wasn't in the sample. It's possible it wasn't even in the population. So that's what you've got to remember. Now, I want to talk about a median next. The median is another measure of center. The median is a number that splits the data set in half. Half of the data data values are less than the median, and half of the data values are greater than the median. This is something that your book gives you. I just left it here in case you saw it on Alex, but I'll give you a better way to do this. But it says the procedure for computing the median differs depending on whether the number of observations in the data set is even or odd. And I'll actually give you the same way, but you don't have to memorize that. All right, so I want you to look at this problem. During a semester, a student took 5 exams. The population of exam scores, and it gives you the population. And I want you to find the median. So what you need to do, if you find the median, and I like this way of finding it the best. It's like what you would have done back in the middle school. Put your data in order from least to greatest. Now, here's my favorite way to find the median. I'm going to do this, and I'm going to say, okay, it's not the first term or the last term. It's not this or this. You just cross them out. So this is the median. The median is 83. All right, now look at this next one. I'm going to put my data in order. I'm going to do the same thing. And it says 8 patients undergo a new surgical procedure, and it gives the days of recovery. The other one was about exams. Here's what I'm going to do. I'm going to say it's not the first or the last. It's not this, it's not this, it's not this, it's not this. And this is that same thing as that even and odd, but to me it's just easier. If you can't keep crossing out or you wouldn't have anything, what I'm going to do with these two numbers, they're both in the middle. I'm going to average them. So I'm going to say 15 plus 19 divided by 2. And you probably know that in your head, but do 15 plus 19, enter 34 divided by 2, which is 17. And that is the median. Now, I'm going to show you another way. This is not necessary for this, but it will help us in a couple of sections if you get this a different way. And this is by measure of location. And if you look at your data, like everybody go back to this first one. This 68 is location 1. 78 is L2, L3, L4, L5. And another way to do the median is you say, okay, the median is in the middle. So I'm going to do this. I'm going to do measures of location. And I'm going to do 0.50 because I want the middle. Okay, I want 50% on each side. And I'm going to do 0.50 times n, the number of items in my list. All right, so this time it would be a big N because it was population. But I'm going to do 0.50 times 5, which is 2.5. Now, this 2.5 is a measure of location. Now, if this is a decimal, and it is, you're going to round up. And I want you to get this, like I said, just a little bit today. We'll do it much more in lesson 3.3. So my median is in location 3. Go back to your data set, look at L1, look at L2. This is L3, that is a median. And that's a helpful way to do if you have a very large data set, because crossing out the numbers is hard with a large data set. All right, look at this next one. I'm going to say, okay, L equals 0.50 times 8. L equals 4. Now, if this was a decimal, we would round up. If it's an integer, you say, okay, I'm going to look at L4 and I'm going to look at L plus 1, location L plus 1, which is 5. So what I'm going to do is average L1, I'm going to average L4 and L5. Okay, so I'm going to look at my data. Here's L1, L2, L3, L4, L5. That's exactly what we did. We averaged L4 and L5 and we got 17. And like I said, not necessary for this unit at all, but it will help us when we do a lesson 3.3. Both the mean and the median are frequently used as measures of center. One important difference is that the mean is more influenced by extreme values than the median. And we're going to see that here. A statistic is resistant if its value is not affected much by extreme values, large or small, in the data set. The median is resistant, but the mean is not. And if you look at this question, it says 5 families have annual incomes and it gives their incomes. And one of the families won the lottery, so their income increased to $1,025,000. They won $1 million. So here's what I want you to do. I'm going to come down here and I'm going to do before, and I'm going to list my incomes. And I'm going to list after. And that 25,000 increase. So I'm going to start with the 31,000. And that the 25,000 becomes that million and 25,000. All right. So what I want you to do is pause the video and find the mean of the first, the before. And the mean, add them all up and divide by 5. And what you should get for your mean is 38,000. And the median, I'm going to do this. Not the median, no. The median is 34,000. And if you see, they're not really that different. All right, do the same thing with after. Pause the video and find your mean. Add them all up, divide by 5. And what you should get for the mean is 238,000. And what you would get for the median, when you do the median, if you look, now the median did change a little bit because the measures of location changed, but the median, it's possible the median wouldn't have changed at all. All right, so what we're going to say is the extreme value influences the mean a lot, increasing it from 28,000 to 238,000. In comparison, the median has been influenced much less. It went from 34,000 to 44,000. Now, and here's what we said. The median is resistant to outliers. And the mean is a non-resistant measure. The mean cannot help being drawn to that big number or that small number or whatever it is. That's why you don't want to get a 0 on an assignment, because your mean is drawn to that 0. It brings your average grade down a lot. All right, now I want to look at some shapes. And if you look at these shapes, histograms will turn into curves. We'll talk about that later. You'll see them turn into a curve. And I want to talk about the mean, median, and the shape, I'm sorry. The mean and median measure the center of a data set in different ways. When you have a data set that is symmetric, like this first one, bell-shaped, what happens is the mean is equal to the median. All right? When you have a data set like the second one that is skewed to the right, I've got the tail going to the right. There are large values in the right tail. It's like the one we did with the lottery when they won the $1 million lottery. The median is resistant. The mean is not. The mean is generally more affected by these large values. So if you have a data set that's skewed right, the mean is noticeably greater than the median. When you have a data set that is skewed to the left, like this, the tail's going off to the left, say one of the families lost their money and their income went to 0, the mean is noticeably less than the median. And here's what I say about this, and this is kind of how I remember it. I'm going to get back up here and I'm going to write it. I say that the mean follows the tail. It cannot help it. Okay, so the mean goes towards big numbers. The mean increases. The mean goes towards smaller numbers. The mean decreases. It cannot help following the tail. Which is better? That depends. Okay, so which is better? That depends. The short answer is neither one's better. But here's what I like about the mean. I like the mean because it takes every value into account, not just the middle. But the disadvantage is that it's highly influenced by extreme values. It is not resistant. You saw it in the lottery problem. What's good about the median? I like the median because it's resistant. Okay, so the median is resistant. But what's bad, the median only depends on the middle value or the two middle values, and we average them. So that's what is bad about it. All right, what I want you to do with this first problem, I want you to do this by hand and find the mean, and I want you to put it in order and find the median. And then I'm going to show you how to do this on the calculator. And you can save time by doing that process on the calculator. All right, so I want you to pause your video, find the mean and the median, and then I'm going to bring the calculator up and show you how to do this on the calculator. what you should have found, and notice that it told you it was a sample. You should have found X bar is equal to 68.5, and the median is 74.5. Now, I want you to be able to do both of those things by hand, especially on a real small sample like that. But here's what you do on the calculator. If you have a big data set, I'd use the calculator. Go into statistics on the calculator. And I'm going to go to that first thing that says data. And I'm going to enter these numbers in my list. So I'm going to enter the 69 and so forth. All right. Notice that it gives you the frequency one. We'll talk about that more in chapter 6. Right now, don't worry about that frequency at all. And what I'm going to do once I've entered it is I'm going to go up to the top and I'm going to go to stats and I'm going to push enter. And the stats tells you a lot about this data set. It tells you things that we're going to use later. But what I want for this right now is the mean. Now notice that's the population mean. That's the same no matter if it's population or sample. It's 68.5. And what I want is the median. And if you look up there, there's the median at 74.5. And if you keep going on your calculator, you see the sample mean, and that's 68.5 as well. When you look at this second question, it says someone surveys the family in a certain town and reports that the mean number of children in a family is 2.1. Someone else says this is wrong because it's impossible to have 2.1 children in a family. Is this correct? And this is why it's not correct, because 2.1 is the average. And if we did this in our class, it would likely be somewhere between 2 and 3. It would not probably be 2 or 3 or 1 or any of that. It would probably be something like 2.1. Pause the video and try these 4 questions and then turn it back on and check your answers. I'm going to start with 2. I think 2 is going to be symmetric because the mean and the median are equal. I'm going to do 1 next. The mean is greater, so it's pulled to the right. It's pulled to big numbers. I think this is skewed right. The third one, the mean is less, so I think that it is skewed left. And the fourth one, the mean is bigger, so I think that it is skewed right. And notice each time I said I think, because you cannot tell unless you look at the data. Now, I want to talk about mode. Sometimes what's referred to as a measure of center is the mode. And you don't want to refer to that as a measure of center because that's not correct. But a lot of middle schools and stuff do that, and I'll tell you why. But here's what the mode is. The mode of a data set is the value that occurs the most. If 2 or more values are tied for the most frequent, they're all modes. So if you've got 2 or more, they're all modes. However, if the values all have the same frequency, we say that the data set has no mode. And when you look at this question, it says 10 siblings were asked how many siblings, 10 students were asked how many siblings they had. The results arranged in order are listed. And what the mode is, you can see it, especially when it's in order. The mode appears most, it's 1. Now, here's why you don't want to call mode a measure of center, because it can be measure of center. But when you look at this one, the mode is clearly not the measure of center. It can be the biggest number, the biggest, the smallest. It can be anywhere. Why they call it a measure of center is because, like I told you at the beginning, most of our work is going to be done with this, with the bell-shaped curve. And if you look at a bell-shaped curve, the mean equals the median equals also the mode. And in that case, it is a measure of center, but definitely not in every case. When you're doing qualitative data, eye color, something like that, qualitative data cannot have a mean or median. That doesn't make sense, but it can have a mode. Pause the video and see which car make is the mode. And you should have come up with Toyota. All right, now the last thing we're going to do is something called a weighted mean. And a weighted mean is something like your grade in our class. Each category counts a different weight. It's likely in all of your classes you have weighted means. And a weighted mean is a mean in which some numbers count more than others. They have a bigger weight. To compute a weighted mean, we assign a positive number called a weight to each number, with the numbers that count more getting the larger weight. So here's the formula for this weighted mean. Here's your data. Here's your weights. What the weighted mean is you multiply your weight times your data. Your weight times your data all the way up. And then you divide by your weight. And it's kind of obvious, except sometimes I think it's hard to tell what the weight is, okay? But the multiplication doesn't matter. It doesn't matter how you multiply them, but you need to make sure you get the weight correct because that's what you're going to divide by. And when you look at this first question, last semester Joe took 4 courses. He got an A in statistics, a B in psychology, a C in English, and A in music. An A is worth 4 quality points. That's the weight of an A. Okay, how much does the A count towards his total? That's his weight. A B is 3 quality points. A C is 2, and so forth. Now, here's what I like to do. I like to make a table for this, and I'm going to do this. So I'm going to make a table, and I'm going to call it my weight and my data. All right, and he had stats and psychology and English and music. All right, so stats, the weight of stats is how much does it count? It counts as 5 credits, and he got an A, it's 4 points. Psychology weight is 4 credits. The data, he got A, B, 3 points. English, the weight is 3. He got a C, 2 points. And music, the weight is 2. It's a low credit course, but data, he got an A again. So his the data is 4. Now, what you're going to do when you're doing this, you're going to multiply weight times data. So 5 times 4 plus 4 times 3, etc. And then you're going to divide it by, I think this is the hard part. What do you divide by? You're going to divide it by the weight. And the weight is how much it counts. The stats counts more. 5 credits, 4 credits, 3 credits, and 2 credits. Now, you saw how I wrote that numerator. I'm going to go into calculation. If you want to clear your calculator, hit Shift and clear. And I'm going to type it just like it is. I'm going to type it with parentheses. And I'm going to push enter. And I get 46. And the denominator, I'm going to add it up. And I get 14. And I'm going to divide 46 divided by 14 for his GPA. And I'm going to do 2 decimal places for GPA. I'm going to say his GPA is 3.29. And once, like I told you, the weight is how much does that count towards what's going on. The weights are different. The credits are different. Okay, so his A in stats weighs more than his A in music.